Good evening, ladies and gentlemen, lovers and seekers, those who are lost, and those who are found. Tonight, I will be reading from the compilation titled Outlaw Creative, The Geometry of Life. Tonight's reading will be from the chapter titled On Geodesic Curvature. That being said, let's get started, shall we? 1. Relativity curvature. What it actually means. The shift Einstein made. Before Einstein, gravity was treated as a force. Newton, mass attracts mass. Einstein, mass curves spacetime. That sentence sounds poetic. It is not. It is geometric. The key idea is this. Objects do not move because a force pulls them. They move because spacetime itself is curved. They follow the straightest possible path through a curved geometry. That's the deep shift. What is spacetime? Spacetime is a four-dimensional structure. 3 spatial dimensions, x, y, z. 1 time dimension. They are not separate entities. They are mathematically fused into a single manifold. An event is not just where. It is where and when. Coordinates look like this. X, Y, Z, T. Mass and energy distort this manifold. That distortion is curvature. What does curvature mean? Not bending like a rubber sheet. That rubber sheet analogy is helpful but misleading. True curvature means the geometry of space changes, so that straight lines are no longer straight in the Euclidean sense. The shortest path between 2 points, called a geodesic, changes shape. On a flat plane, shortest path equals straight line. On a sphere, shortest path equals great circle arc. That arc looks curved in 3D space, but to the surface itself, it is straight. Curvature is not visible from inside the geometry. It is detected by how paths behave. Gravity is curvature. Mass tells spacetime how to curve. Curved spacetime tells matter how to move. That's the field equation in conceptual form. If Earth did not pull the Moon, instead, Earth curves spacetime. The Moon follows a geodesic in that curved geometry. The result appears as orbit. Nothing is being pulled. Motion follows curvature. Light also follows curvature. This is measurable. Gravitational lensing. Distant stars appear displaced because light bends near massive objects. That bending is real. It is experimentally verified. Time is curved too. This is the part people miss. Gravity doesn't just curve space. It curves time. Clocks run slower in stronger gravitational fields. This is measurable. Atomic clocks at different altitudes tick at slightly different rates. Satellites must account for this or GPS would fail. So time is not universal. Time is local to curvature. The deeper the gravity well, the slower the clock. That's not metaphor. That's engineering reality. So what is curvature fundamentally? Curvature means the rules governing distance and duration change. Flat geometry. Parallel lines stay parallel. Curved geometry. Parallel lines can converge or diverge. Flat time. Clocks tick uniformly. Curved time. Clocks tick differently depending on position and field. Curvature modifies path behavior and rate behavior. That's physics. Now, let's move carefully into analogy. 2. The geometry of attention as analogy, not physics. We do not say attention curves spacetime. That would be false. But we can use curvature as structural metaphor carefully. Attention as geometric field. Attention concentrates cognitive energy. Flat attention, diffuse, scattered, low intensity, wide coverage. Curved attention, focused, high intensity, narrow field, deep penetration. This parallels concave geometry. Curvature concentrates wave energy. Focused attention concentrates cognitive energy. Energy per unit area increases. Clarity increases, but coverage decreases. Curvature always trades range for precision. Path behavior under attention. In flat mental state, thought moves in linear sequence. Associations are shallow. Reaction is reflexive. Under focused attention, cognitive pathways reorganize. Irrelevant stimuli diminish. Signal-to-noise ratio increases. Neuroscience supports this. Attention alters neural firing synchrony. Focused states increase coherence across specific networks. Diffuse states increase randomness. No mysticism, just signal concentration. Time perception under attention. Now this is where analogy gets interesting. Physics says gravity bends time. Psychology says attention bends time perception. Under deep focus, time compresses. Under stress, Time dilates. Under boredom. Time stretches. Under crisis. Time fragments. The clock doesn't change. The experience does. The analogy is structural, not literal. Gravity modifies clock rate physically. Attention modifies clock experience cognitively. Both alter duration behavior relative to field intensity. Mass energy density changes time rate. Cognitive emotional intensity changes perceived time rate. That's the parallel. Curvature as path determination. In relativity, objects follow geodesics in curved spacetime. In cognition, thought follows salience in curved attention fields. What is salient bends mental trajectory. If anger dominates, perception curves toward threat detection. If curiosity dominates, perception curves toward pattern recognition. If fear dominates, interpretation curves toward worst-case modeling. Emotion is mass in psychological space. It warps interpretation pathways. Again, analogy, not literal physics, but structurally consistent. High emotional mass bends cognitive geometry. Stability and collapse. In spacetime, extreme curvature creates singularity, black hole. Paths collapse inward. In psychology, extreme fixation collapses cognitive flexibility. Obsessive loops, rumination spirals, tunnel vision. Curvature too strong eliminates alternative geodesics. There is no flat alternative path. Moderate curvature organizes. Extreme curvature traps. That parallel is structurally sound. What this means practically. Relativity teaches. Motion is geometry dependent. Psychology teaches. Thought is salience dependent. Curvature determines trajectory. Flat geometry allows multiple equal paths. Curved geometry biases path behavior. Attention curvature determines cognitive trajectory. The more focused the field, the fewer viable paths remain. That's powerful. It means, where attention rests, behavior flows. Not because of mysticism, because neural reinforcement strengthens pathways. Curvature in physics changes shortest path. Curvature in cognition changes most probable path. The clean structural synthesis. Physics. Mass curves spacetime. Curvature determines motion. Time rate varies by gravitational depth. Attention analogy. Salience curves cognition. Curvature determines interpretation. Time perception varies by cognitive intensity. In both systems, field intensity modifies path behavior. That's the through line. Why this matters to me. I am drawn to curvature because it implies structure over force. In relativity, nothing pulls. Geometry guides. In cognition, nothing forces. Salience guides. This aligns with your acoustic mirror interest. Curved walls don't shout. They redirect. Curvature does not add energy. It redistributes it. Writers do the same. They bend signal. They don't create signal. They change geometry of interpretation. The hard line. Curvature is not magic. Curvature is constraint modification. It alters allowable paths. Flat equals many equal trajectories. Curved equals biased trajectories. Mass bends path. Attention bends interpretation. Signal concentration bends clarity. Time curvature bends rate. Same mathematics, different domains.